Okay, the next thing we need to do, we need to tell our machine how to set the speed when we make a speed request. And we know that the value needs to be from 0 to 255 out to our speed pin, and how we would do that would be digital write. That's the Arduino, part of the Arduino library, a function called digital write. Our direction pin, for what direction we want to go, comma, and of course a 0 would be, I think it's forward in that thing, and a 1 would be reverse. But I am not a fan of just putting numbers in spaces that later on somebody's like, well, what is that? So I like to prevent that. So what we can do is we can do something new that I haven't covered yet. We can go back to our blueprint, and we can go back to our bidirectional motor, and we can set some properties. Properties are just simply names that are associated with numbers. In other words, when I say the word X, I actually mean the number whatever, and it's not actually a storage space. It's just telling the compiler this so that it will replace that name with that number later as it processes our code. And we do that, it's referred to generally as an enumeration. Enumeration is a name that is actually representative of a value. And so C++ has this ability called enum, or enumeration. And we don't really need it available to the entire object. We really only need it private to our pins. So enumeration, and then we can make a context for what enumerations we want to define, and we separate them with commas, and we can say forward equals 0, and then we can say reverse equals 1 equals 1. Now there are some properties though that I'd like to make public, or might like to make available to the entire object in its namespace, in its code space, and not just part of the blueprint. I want to make the entire object available to the entire object. Remember what I said about, if something's defined in this context, every subcontext can see it. Same kind of thing. And I want to make another enumeration up here, and this is going to be more public with a code space or context. What I want to do is I want to say maximum speed forward, and we know that's going to be a 255, and then maximum speed reverse, because I'm going to do it in the spirit of how we can manipulate this thing versus what the percentage of the pins. Maximum speed reverse is going to be negative 255, and of course stop or stop is going to be 0, means stopped, or easier said, just stop. Now I use 2 P's because some programming languages, if you use the word stop, it's a reserved word. I don't think it is in C, C++ or anything, but I just like to stay with the same practice and just use 2 P's for this word stop, just to be safe, play it safe, in case some other routine somewhere is using that same reserve or word as a reserve word. That looks pretty good, and those are public to the entire, those are available to the entire object, blueprint and all. And so we'll do that. And now we come back over here and we can say, hey, digital write the direction pin forward, forward. And of course, to make it go forward, we also need to set the speed, and that's an analog write our speed pin, comma, the actual speed that's being requested. Yeah, that looks pretty good. Why do I have a typo? Because I typed analog write. and a long analog. Hey, dummy. Okay, now, of course, we're going to make this where if we go, if we set a positive value, it wants to go forward, and a negative value, it wants to go backwards. So we have to do some logic here. We have to figure out whether we're going forward or backwards, and then change the state of direction pin. And obviously we can't send a negative value to our analog write. We have to make a positive. We have to turn it into a positive. So we do this with an if statement. If a frog had wings, he wouldn't bump his butt when he hopped. The biggest word in the dictionary is if. If. What is the if going to eat to make it true? And then what context are we going to apply when the if statement is valid or true? What context, what things are we going to do if it's true? And if it's true, if the speed is less than 0, that means we have a negative. And then we say else, in other words, otherwise, if it's not a negative, we can assume it's positive, and we can do this right here. And we can go ahead and set the direction forward, set the speed. If it's negative, and if it's less than 0, it's a negative value. We need to set the direction to reverse. And then we can say the negative of the negative speed, which any negative of a negative is a positive. Yeah, so the negative value, we know it's negative because we checked to make sure it was negative. The negative of the negative will flip around and make a positive, so that will send a positive value to our analog write. That cures that. But we have one other problem. Remember what I said earlier? The uint16, or the the integer 16-bit value can go from 0 to minus 32,767, not 3255, and positive 0 to 32,767. So it can go larger than what we can handle, what this pin and this analog write routine can handle. So we need to clip its wings, per se. And so we can say if, and of course we know we're negative at this point, we have a negative value, if speed is less than minimum, what did I say? Oh, maximum. Hey, dummy. Maximum speed reverse, because this is our reverse section. Then what do I want you to perform? What task should I have you do? I want to clip the speed to the maximum and just clip it off. So we will do this right here and set this to assign speed to maximum. In other words, if speed is less than, because when you're going negative, less than means it's beyond the range. When you're going positive, it's greater than, it's beyond the range. So it's the opposite. So yeah, speed is, we're going to clip that off, and of course we need to do that. We're going the other way. If speed is greater than the maximum speed forward, then speed equals maximum speed forward. There we go. That ensures that we don't get erroneous control signals if whoever or whatever or however this got called and requested to action to happen isn't somehow out of bounds. Looks pretty good. Now, if you program your stuff correctly, you don't need to comment stuff. Somebody that doesn't even know C++, they might not be able to read the syntax very well, or the else statement, if statement, and the parentheses and the ints and the kind of crazy stuff going on here. But you can, anybody who has some amount of intelligence can say, hey, a bidirectional motor blueprint, set speed, okay, that kind of tells me there's some kind of a speed blueprint. If the speed is less than 0, okay, max speed reverse, okay, set it to max speed reverse, set the direction pin to reverse, set the speed pin to the speed. You can kind of see what's going on in here without having to comment the holy crap and ill dignity out of it. That's the way I like to program. I like to program with words and sentences. My variables are in a very standardized format. The first word is never capitalized. all the subsequent words are capitalized. You cannot put spaces in your variable names in C++, so you jam them together to overcome that and use capitalization for all the subsequent words. Do my lines of code get long sometimes? That's an example here. We split this one down. I would rather write a paragraph and understand what's going on than to write 3 words and have to look it up in a dictionary 15 times. That's how I like to code. That's the difference between, I think, good coding practice and standardization of the way you write things and the way you do things. Keeps things on track. It keeps them understandable. It keeps them, consistent. And it's very important, very important. This language will overwhelm you, and your programming abilities will overwhelm you, and you will get lost so fast if you don't adopt good programming and good practices right out of the gate, right as you're learning to use this language, or any programming language, really. What good is it when you watch this tutorial on the stupid internet that says, here's how you print hello world. You click this button, click this button, click this button, and the editor does it for you. Oh, don't worry about all the crap around here. Look, here's the words hello world. Doesn't teach anybody anything. And it only encourages bad practice. So, that's my rant. I think we're done with a bidirectional motor. It looks really good. We have everything we would want it to have in it as an idea. All the ideas are present, and all the how to do those ideas are present, and we can move on. The next thing we can do is we can go to, we have this, we have a left and right. There's no reason to make separate left and rights now because it's generic, and we can say, we can have, when we make our tracks, we will move up this rung, and we'll get smarter as we go, and we'll increase the intelligence of this device, this little robot, as we move up this range, as we move up this pyramid of final result. We can have the tracks say, make me a left motor and use these pin and this pin, pin 12 and pin 3. Make me a right motor, use pin 11 and pin whatever that pin is. So that's why we coded it this way. When you make one, use these pins and do this, and then here's how you do all that stuff individually. So that looks good. We're done with that part. Okay, before we move on and we start building other objects, I want to put this into a little bit of perspective for people trying to learn this. How does this come into view when we actually use this? So I'm going to go to my main program. This Eclipse software, it sets up this, kind of Arduino thing that we explained before. And so I'm just going to use the main program space. This is like the INO file in Arduino is like the main program, like the starting point of where your compiler is going to look at your code and see what you want to do. All these header files and CPP files, they're all just, I can include that stuff in my program. At this point, they're just individual files. So to put this object in perspective, and why we did this, why we made some things public and why we set some properties and things. Let me just show the use of an object as an example real quick here, just to kind of put this whole thing in perspective. We tell the precompiler, the secretary, include in our main program here our object now, which is going to be bidirectional motor. And then once we do that, we can then begin to use this information to create one. We have this idea. Here's how you do the idea. Now we need to make one. We actually want to make, from all that information, let's say we had the information, let's say we made a header and CPP file for this entire calculator. That doesn't make a calculator. That makes everything needed for a calculator. No code will end up in the device or in the Arduino if we don't make one. So let's make a bidirectional motor so that it ends up in the Arduino, and the Arduino knows what a bidirectional motor is. And how we do that is we take our object and we refer to that, and then we do the double colon, so we want something within the context of our bidirectional motor. And what do we want to build our actual motor out of? Guess what? Our blueprint. So we use that blueprint, that drawing, that idea to create, let's just say left tank track. And then of course it's going to require us to, for those 2 pins, because our blueprint is going to require it, it's going to require those 2 pins. And of course we know it's going to be 12 and 3 by looking at that. Our pins 12 and 3. This is a quick dirty example on how to putting an object into actual use and creating one, and taking that idea and bringing it into something functional that works. You take your idea, you create an actual unit based on that idea. Of course, we say, by the way, we need pins 12 and 3 to be those pins that we didn't assign, or those numbers, those values we didn't assign. And now once we have a working unit, we can then go in our setup program, or in our other code spaces, or in our other areas of the program, or in our what we want to do, and we can say, hey, left, and this is where it all comes in, left tank track, because you refer to it by the name you give it, not by its blueprint or object idea, but by what you named it, because that's the individual one you made. And we can say, hey, and then because it's the one you made, instead of using the double colons to access something, you use the decimal point. You say, hey, left tank track dot, and then dot what do you want? Set speed. How about we set the speed for it? Or you know what? When we do our setup program, we need to initialize those pins on the Arduino chip. So we say dot, hey, begin, which is going to initialize the left tank track, the bidirectional motor. It's going to say the pin mode's output. It's going to run that, and it's going to install that code into our program, because it knows now how to do those things. So we say begin, and of course the next thing we could do after that is we could say, left tank track dot set speed, and of course we can say, to begin with, why don't we just say 0 for stopped. But you know what? We can do one better than that, because we have a generic object definition for what this bidirectional motor can do. We can say bidirectional motor, within the context of bidirectional motor, we can say, hey, guess what? Look at those public enumerations that we can now refer to. And we don't have to dig into the blueprint or anything else. We can just say, hey, object, I want to go maximum speed forward. And there you go. This program right here takes that track, that idea of a bidirectional motor, and we call it tank track. We give it the pins, and we simply say, begin, which means, set yourself up to operate. And then we say, hey, set the speed to maximum speed forward. We don't need to comment this code. We don't need to dig through sub-libraries to find out what this is doing right here. It's obvious, it's concise, and it's very straightforward, and it's not overcomplicated. So that's why I program in this method, and this method is repeatable, it's consistent. You end up with the same ideas over and over and over, and you don't get lost because of that. It gives you the ability to program very complex systems with the same simple building blocks over and over and over to build upon. And that's why I do things exactly this way, because it just puts it in a system that is very easy to learn and follow. So that's the perspective of why I build objects this way, why I take all the time to do it like this, because as we go through this tutorial, we're going to repeat this process. Now we're going to start repeating this process for each of the other objects. But don't jump ahead of the end, because as we repeat this process, we're going to make changes. We have different. We're going to keep adding more to this and growing upon this idea as we go along, because our different objects, our different hardware devices and things have different needs and requirements. And the next layer up, which is our we go over here to our drawing. The next layer up, which is these devices, as we go from a hardware layer which says, hey, this is how you do this and this is what you do, don't add anything to that. That should be as dumb as possible, but as smart as it can be for what its basic task is to do. But you shouldn't add any functionality to it other than what it's supposed to, what it's actually supposed to do or perform. At this layer here, you then begin to take things in tandem and increase intelligence by the use of the fact that you have multiple objects that you can interact with each other to create more complex intelligence and more complex functionality and more complex situations, and name them in very simple ways. It's like you have a boss at a company, and he tells his supervisor, to go and make sure all the employees show up to work on time. And the supervisor goes to each employee and says, hey, make sure you show up to work on time. Make sure you show up to work on time. And the employees, you don't have to tell the employees. Well, the employees already know, well, they should punch the time clock in so that it doesn't show that they're late. That's kind of the same thing. You delegate responsibility upwards to be more and more generalized, and downwards to be more and more specific. And that's how you program things in a way that will never ever overwhelm you. You can program the most complicated systems you can imagine by just sticking to this format and just sticking to these ideas and using these same set standardized ways. Does that make sense? I guess it does. I don't know. That's how I like to do things. I think that's a good way to just really get started in this language without it overwhelming you so much. It's a good way to start out the right way, to start out by not looking at all this stupid syntax and what do I got to do now, and what do I got to do now, and what do I got to do now, and next thing you know, maybe you make something, maybe it works, but then next week you want to change it, and you're like, well, where do I put that change in my code, and at what part, and how do I insert this, and how do I... Forget all that. If you think like a person instead of like a machine, you never run into that. Built like this, you can just simply go to that layer and say, add this thing, or change this thing, or increase this intelligence at this point, or delegate this responsibility out this way. Because that's the way people work. That's the way the world works. And that's the way your programming should work too.